Welcome again. My name is Chris with Tampa-Hillsborough County Public Library. I'm joined this evening by Tanja Diederich. Hi, Tanja. Welcome and welcome everyone. This program is part of our summer reading. And if you don't know, it's underway. And our theme this year is Tales and Tales. And we have a lot going on. Of course, a lot of events like this, but we have book lists, reading challenges, prizes, and a whole bunch more. And you can learn about it at our landing page, hcplc.org/summer. And also, we have a reading challenge going on this summer, like in previous summers. And we have challenges for adults, tweens and teens, and kids. And you can register at hcplc.beanstack.org. There's a lot more information there. I like to go into detail about it because it's a lot of fun, but you can learn more there about prizes and all of that. And of course, I went over my title slide. Tonight's program is Dry Ice Comet Tails, and we have Tanja Diederich with us, who will begin shortly. I just have a few more things to go over. This program was funded by the Tampa-Hillsborough County Children's Library Foundation, so we'd like to give them a big thank you for helping us out and helping us deliver these fun programs for you. And as usual, we have a book shout out. And tonight's book is Comets, Lighting Up the Sky by Seth Kingston. This is an ebook available in our Hoopla collection. With Hoopla, you don't have to wait for these titles. They're available immediately. And you can find out about this book and other books if you go to hcplc.org/books. All right, Tanja, I am happy to introduce you. Tanja Diederich is with us this evening. She's going to be showing you some really cool things about dry ice and experimentation. And I'm going to turn off my camera and microphone and let her take it away.
Good evening, everybody. I'm so glad that you joined us today. There are a few things that I want to teach you about dry ice. First of all, it is frozen carbon dioxide. Notice that I'm touching a cup right here, but I'm not touching the dry ice. Okay, dry ice is very dangerous. It's about 109 degrees below zero. I do have gloves with me in case I need to pick a piece up. So that is very important. It's about 200 degrees cooler than your body temperature. And so you can really burn yourself very badly. Now, the other thing to note is that because it's carbon dioxide, and all of you know that we breathe out carbon dioxide and inhale oxygen, it is super important not to breathe it in. Okay, you can see I'm holding it relatively close to me, but you can also tell that as it's sublimating, turning directly from a solid into a gas, that the carbon dioxide actually flows down. Now, the reason for that is that carbon dioxide is heavier than the air we breathe. And so the air we breathe is above it, and the carbon dioxide flows below. Okay, and you can actually see I'm making a few big bubbles that are pumping out the extra pieces right there. Okay, so the first thing I'm going to do is I'm going to show you a couple of tricks with carbon dioxide with the frozen dry ice, but then I will tell you a little bit more about comets, since that is the name of our program. And in this case, we're talking about the tails of comets, but we're actually going to make a little comment at the end. So the first thing I want to show you is a neat trick I learned recently. And what you do is take a little bit of dry ice and stick it into a container. You let it sublimate. And what sublimate means is it turns directly from a solid to a gas. There's no liquid stage. Now you'll see there is some liquid involved, but that's because I put water to help the dry ice sublimate quicker. What I'm trying to do is make a really big bubble. The way that you do this is you soak a string in some bubbles, and then you have to run it really quickly over the glass. There we go. All right, so got it going. And now you can see the bubble is forming. It sort of looks like a great big crystal ball. And we'll let that continue to grow a little bit. Okay. In the meantime, you can see that the dry ice is not sublimating as much, and it's because it's so cold, it actually makes the water cold. And because of that, it doesn't sublimate. It sort of slows down. And if you add a little bit of warm water, and have it in a thermos to keep it nice and warm, add a little bit more warm water, then you can see it speeds up the process a little bit and makes all these great bubbles. All right, now you can see the pretty big bubble is going well. Let's see if I can make a small bubble as well. Sometimes if you add a little bit of soap to the water, what you end up doing is getting a bunch of little bubbles. So then you can end up with lots of little bubbles getting formed, which is pretty cool. Whoops. Eventually, the bubble won't hold. That's a really good one. It took a little while to get it started, but it looks pretty good. All right, so what we're gonna do is, whoops, there we go. Notice that when it popped, that all of the carbon dioxide went down, okay? And it's because we basically breathe O2, and that has two oxygens, and carbon dioxide is two oxygens and a carbon. And so because of that, it's heavier and it flows downward. Add a little bit more warm water. And a little piece of dry ice. And we'll see if we can't form another one. Now, a trick that I learned is that you have to make sure that you start at the very end of the rim and you have to go really quickly. Otherwise, it'll burst the bubble before you get started. If it doesn't work immediately, then what you're going to do is just run it again. Let's see, this one is not cooperating with me. All right, we're just gonna leave it alone for a little bit. Let's see if the small one will do it. Oh, it's going too quickly. Okay, so let's talk about comets, okay? So people started noticing comets thousands of years ago. Now, they did not realize that what they were seeing was frozen balls of muck, the leftover building blocks of our solar system. So when our sun formed, it formed from lots of dust and gas that had been left over from a previous supernova. And then after the sun formed, the planets coalesced, and then the moons coalesced around the planets. And after that formation, there were bits and chunks that were left over, and those ended up being comets and asteroids. Comets and asteroids are relatively closely related, except that comets have a lot of water. And scientists believe that they might have been the reason that we got water on this planet, if you're looking for a scientific purpose for it. And so when those comets come around, they actually deposit lots of particles, pieces of dust, tons and tons of dust in our solar system, and then the Earth runs through the dust, and that's where we get meteor showers. And we've got lots of different types of comets. There's actually trillions of them. We don't see them very often because they don't visit our sun very often. They hang out in an area called the Oort cloud. And the Oort cloud is on the very outer edges of our solar system, and there's trillions of comets out there. And then closer in, we have some smaller areas of comets in the Kuiper belt, and those ones take a very short period of time to come visit us, like Halley's Comet that comes every 76 years. It comes out of the Kuiper belt. And then we have incredible comets like Hale-Bopp that might not be back for several thousand years when it comes back to visit us again. Now, the cool thing about comets is that comets contain carbon dioxide, oxygen, water. They contain some yucky things like arsenic, methane, ammonia, things like that. And so when we make our comet, we're going to make it with carbon dioxide and water. We're going to have something to represent the organic material, all the carbon for the organic material, and then we're going to have something that represents the muck, because basically comets are frozen, dirty snowballs that are traveling in space. They come around the sun, they heat up, they produce a tail, they come all the way back out to the outer reaches, and they lose the tail. They only have tails when they come really close, so they have to get as close as about Jupiter's orbit. Okay, when they get to about Jupiter's orbit, which is about 500 million miles away from us, then they produce the tail, and the tail gets bigger and bigger and bigger. And then when they come back around and passes Jupiter's orbit, then the tail is no longer. So that is a neat thing about comets. Now we have another type of comet which is really famous, and they're called terminal comets. Now terminal comets are the best comets because terminal comets run into things such as Jupiter or Saturn, maybe the sun, and that's the end of the comet. And the good thing about that is if it runs into Jupiter, it runs into the sun, it's not going to run into the Earth, which is what we're trying to avoid. So those terminal comets, one of the most famous was Shoemaker Levy 9, because we actually watched it hit Jupiter, which was really an amazing sight to see. I wanted to show you one other trick with dry ice that's really cool, and that is the screaming quarter trick. Okay, so I'm going to put the quarter in some warm water, and then you stick it in the dry ice. Okay. So if you take a look, you can see that it's moving, and not only does it move, but it makes this really strange sound. Now, I've tried it with a lot of different coins, but really the quarters work the best. Now watch, the nickel's going to show up my quarter. Let's see. Not that time. There's a good sample. So you can see it also causes it to move. I have no idea why. Okay, what I believe is that maybe as the air sublimates, as the carbon dioxide is sublimating, that what it's doing is that puff of air is pushing the quarter back and forth, but I don't know. Now, by accident, I discovered, because I used the spoon, what I discovered is if you put the spoon in here, it makes some crazy sounds. Like it sounds like an alarm clock, old style alarm clock or an old school bell. And all that is the spoon sitting on the carbon dioxide. So it's just one of those things when it stops moving, it's too cold. If you put it in some warm water, you can just stick it back on it. Now, I'm going to tell you, when you're working with dry ice, you definitely want to have your gloves if you actually touch the dry ice. If you are somebody under the age of 18, please don't play with the dry ice on your own. Please make sure an adult is doing it for you. Okay, stay safe. In my science class, we make comets all the time, which is really fun to do. Now let's see if we can get the quarter to go one more time. Nope, it's not going to do it. Okay, so what we're going to take a look at is a comet like Halley's Comet. You know, it comes around every 76 years, leaves a whole bunch of dust in our solar system. Then the Earth plows through it, we get meteor showers. Our next really big meteor shower will be the Leonids, and the Leonids are in, actually, that's not correct, Perseids are going to be in August, and I believe it peaks at August 12th. Usually around 4 o'clock in the morning. Don't ask me why the meteor showers like to be around 4 to 6 in the morning, but generally they do. The Leonids are in November. Those are the two big ones, but the truth is there are meteor showers pretty much every month. And if you go outside and have lots of patience in a dark sky, you can see lots of meteors pretty much every night, maybe 5, but you got to be in a dark sky. And if you live in Tampa like I do, it can be really difficult because our skies aren't very dark. All right, so let's take a look at our comet. The first thing that we're going to do is we're going to talk about parts of a comet. So there's 3 parts. The first part is this nucleus right in the center. Okay, it's a solid, hard, rocky piece. That's the piece that's traveling through space. And then when it gets to Jupiter's orbit, it starts sublimating as it heats up, and it produces a big coma, big ball of gas around the center. And then as it gets further along, then it produces the tail. Now, the cool thing is you take the tail and you take it to sea level air pressure, about 16 pounds per square inch. The square inch is about this big. Every inch of your body has about 16 pounds pushing on it, but the inside of your body pushes out at the same pressure, so we don't feel it. You'll notice the pressure if you're driving in the mountains and your ears are popping, flying in a plane, or if you're diving really deep in a swimming pool and your ears start to hurt. That's the pressure. Okay. Now, if you took that comet tail, which can be as big as the distance from the sun to the Earth, about 93 million miles, if you took it and put it at air pressure, it'd fit inside of a suitcase. So they don't have a lot of stuff in them. Now, the other thing to know about these tails is that, yes, they have arsenic, and the Victorians actually sold arsenic pills and insurance to make sure that people didn't die from arsenic. But the silly thing is that if everybody was going to die from the arsenic and the comet tails, why is there insurance? And how is the arsenic pills going to help? So in any case, what happened is people didn't understand enough science to know that there wasn't enough arsenic to be a problem. And so it was people taking advantage of others. So keep that in mind if people ever go crazy and say, oh my goodness, there's arsenic in the tail of a comet. Don't worry about it. There's not enough to be a problem. Okay. What we're going to do is we're going to take a plastic bag. Now I want to warn you, there's a hole in this plastic bag. Okay, you have to have the hole in the bag. Otherwise, you might have a very small explosion. Don't want to do that. Okay, and we're going to put some dry ice inside of the bag. Okay, and what this is basically the nucleus of the comet. Okay, so we have the dry ice in there, and you can see it's already sublimating. It's already turning from a solid to a gas. All right, and then we're going to add some of the other parts of the comet. So you know this is the carbon dioxide, and then we're going to add some water. Actually, I think I'll wait. I'll add some muck. How about some muck? Okay, so for muck, I just pour in some syrup. Okay, because basically comets are dirty snowballs. So add a little bit of syrup to make it all icky and yucky. Then I told you there was organic material in the comets in the form of carbon. So our organic material is going to be Oreo cookies. So this is organic material. And we're going to put that in and make this comet even gooier. Okay. And then we're going to add some stuff just to make it look crazy. Ooh, and that reminds me. Oh, please. Oh, please. This will be cool. Hold on just a second. Hold on just a moment. Just one moment. Oh, now I can have red stuff boiling. Okay, so we'll leave that. And then the final thing we're going to add is water, because comets are famous for having water. Okay, so we're going to add our water. And then zip shut our comet. Okay, so you have the nucleus, that's the hard frozen part here. The coma is the bag, that's the big ball of gas that forms. And then we got the tail. And the tail is the dust and gas that's escaping from our comet. Now remember, it's this tail that has the dust that eventually the Earth is going to come through. And when the Earth comes through that dust, then we have those wonderful meteor showers. So when you see a meteor shower and it looks like stars are falling out of the sky, don't worry, it's nothing scary. All that's happening is the Earth is running into the dust that's being left behind by the comets, and it incinerates in our atmosphere. Sometimes there's bigger pieces, and those will land, and those are called meteorites. When they're flying through space, they're called meteoroids. When they come through our atmosphere and are lit up, they're called meteors. And when they hit the ground, they're called meteorites. And so that is where we get our wonderful meteor showers. And keep in mind too, just a moment, each meteor shower is connected to a specific comet. So Halley's Comet has specific meteor shower. Comet Swift-Tuttle is the one that's responsible for the Leonids in August. Encke the little comet that only takes about 3 years to make an orbit around the sun. That one leaves a trail behind also. I think that's the Orionids. And so then you can keep in mind looking up in the sky and see those awesome meteors. All right, so the last one is some cool red soda. And dropping out. I love the way that carbon dioxide does this. Now keep in mind, because this is carbon dioxide, you want to make sure that you're in a well-ventilated room, okay? Have fans blowing, have the air conditioning running, or do this stuff outside, right? So that you don't breathe in too much of the carbon dioxide. Doesn't hurt you to breathe in a tiny bit, but you want to make sure that you don't get it in your nose. If you are buying dry ice, you can get it at Publix. Right now they're out. I can tell you that from personal experience today. But normally it's at Publix. If you're getting it at Publix, they will get it for you. The most important thing to keep in mind is when you pull the cushion up, don't have your nose down there because it brings up an entire flood of carbon dioxide to your face and you don't want to experience that. Okay, so I am ready for questions. Does anybody have any questions for me?
All right. Yes, we have some questions coming in. Let's get to those. So someone asked about the string earlier. They said they're asking, is the string soaked in soapy water? Is that correct?
Yeah, bubbles. So I have it in
Okay.
some bubbles.
Yes.
And I just remembered I had one more experiment to show you guys, but I can answer questions while I put it together.
Yeah, that's fine. All right. Someone else is asking, I guess, when was dry ice discovered? When was that first, historically, when was that discovered? Do you know?
I have no idea. What I can tell you about dry ice, frozen 109 degrees below zero and carbon dioxide. But I don't know when it was discovered. But I do know that pretty much every material has a point where it is a solid.
Mm-hmm.
And so I believe that with understanding the different materials and when they're solid, liquid, and gases, I think people could figure that out.
Okay.
But I do not know that answer.
All right. Someone is asking, what if you put warm water on dry ice?
Oh, that's what I was doing. This one right here.
Yeah. All right.
This container here has really warm water. And if I put the warm water back in here, even though it had stopped, it's because the water had gotten too cold.
Okay.
And you can see because I had bubbles in this, it's making bubbles.
Oh, neat.
So let me slide this around. I'll put it here. But you can see as soon as you add warm water to the dry ice, it just starts up again. Now keep in mind, the reason I have bubbles here is because I have bubbles in it. I put the bubbles in there. That's why the bubbles are forming.
All right. Let's see. Does the soda increase the sublimation of the dry ice because it's carbonated?
No, only if it's warm. So really the soda is only in there for color and to be cool. It's not there because it helps the sublimation, other than keeping in mind that if it's at room temperature, let's say the house is about 70 degrees and dry ice is 109 below zero, that is what, 180 degree temperature change. So for the dry ice, soda is like really, really hot. And so that helps it to sublimate.
I see. All right, let's see. Our next question, someone's asking, what colors can a comet be? Like what colors are comets?
Generally, the comets are going to, they're going to appear white if you can see it normally. Mm-hmm. However, sometimes the gas tails, I have this really awesome picture of Hale-Bopp, and it's gas trail is bright blue. in the picture. So sometimes they can be a little bit different colors. Now you will notice that when you see them on TV, or if you see them in pictures, they might be in different colors. And part of that is because they might be using different spectrums of light. Instead of showing you what it looks like in visible light, they're showing you what it looks like if it was in infrared, or if it was in, what are the others? It could be in X-rays. It could be an ultraviolet. So sometimes they do that so that you can see them in different spectrums.
Okay. Interesting.
The pictures that are from Shoemaker Levy 9 hitting Jupiter were amazing. And it was because it was some of the first pictures that were ever taken by the Hubble Space Telescope. So that was an amazing thing to see.
Are those pictures, I guess if someone were to go on the internet, they could find images of that.
Absolutely.
Someone was asking.
Yep.
Someone was asking the name of that comet, the one that I guess the terminal comet. That's Shoemaker Levy 9.
Yeah. It was Shoemaker Levy 9. It was discovered by Carolyn Shoemaker and David Levy. Both actually, Carolyn Shoemaker and her husband were meteorite hunters, and they knew that by studying comets they could find more meteorites. They weren't actually looking for comets, they were looking for meteorites. And ended up finding this amazing comet. What happened with Shoemaker Levy 9 is it came around really close to Jupiter, and Jupiter pulled it apart into about 19, 20 pieces. I can't remember exactly. And then when they came back the next time, they hit it, each piece. And so when that happened, it was pretty extraordinary. And so that was a crazy thing to see. And it left it like basically with black eye. But for Jupiter, that was like a fly hitting the windshield of a car. It didn't really, and Jupiter was the car. It didn't impact Jupiter at all.
Someone is asking how dry ice forms in space. Is it the temperature that helps with that, or how does that happen?
Well, if it was in an area where carbon dioxide is cold enough, then the carbon dioxide would turn into dry ice, sort of the same way that water will turn into ice if it's cold enough. And keep in mind that, like, for example, on the moon, if you were standing in the sun on the moon, it's about 250 degrees above zero, because you don't have an atmosphere to regulate your temperature. If you step into the shadows on the moon, your temperature drops to about 200 below zero. Same thing happens if you are doing a spacewalk. So if you're outside of the space station and you go for a spacewalk, the space station goes around the Earth every 90 minutes, traveling at 17,500 miles an hour. And so on the sunny side of the Earth, about 250 above zero, shady side about 200 degrees below zero, and that changes every 45 minutes. So if you're someplace cold enough, then the carbon dioxide that's free, such as on Mars, it could turn into a solid. And then if it heats up, like at the equator to about 70 degrees, then it would sublimate.
Let's see. Yeah, I think that's another one of our questions is at what temperature does dry ice melt?
Well, it never melts. That's the funny thing about dry ice. It actually, that's what sublimating is. It goes directly from a solid, just like it is here. So a solid like this is at 109 degrees below zero. And then all the smoke that you see coming off, that's the carbon dioxide sublimating. So there's no melting position for the dry ice.
Okay.
That's dry ice's version of melting is sublimating. I'm going to drop another piece in here. And so there you can see the dry ice sublimating even faster.
All right, we have one more question. Someone's asking, if you touch dry ice, does it give you immediate frostbite or something similar?
Yes.
Yeah, it's dangerous.
Do not touch it. You have to think about this. The inside of your body, about 98.6 degrees, I think. That's more than 200 degrees warmer than dry ice. You have water inside your cells. When you touch the dry ice, the water in your cells freeze and water expands when it freezes.
Right.
Because the water expands, it bursts the cells. And if you're touching dry ice with your hands, it will cause the cells to burst. Now, please know, I don't always have my glove on, but I'm never touching the dry ice. Never. Okay, I either pick it up with the spoon or I pick it up with the gloves. I can tell you, you do not want to touch it under any circumstances.
That's a good point. Yeah, you need safety.
And you also don't want to stick your nose in here.
Right. Okay. Well, how are we with our final experiment here? Are you ready to share?
What, this one? Oh, it's
or the balloon there that you have on the bottle, is that
right here?
Yeah.
So you can see all of the dry ice has sublimated, and all the carbon dioxide is captured inside of the balloon. And that's a really cool thing, is that this is the way that you know that you have all carbon dioxide. So if I take this off, of course you want to do this without breaking the balloon. If you do this, you know that all of the dry ice actually got captured into the balloon. Now let me try something else. I'm going to try one more thing, because I was having a little problem with my crushed ice, because my crushed ice decided that it was going to sublimate before my program started. So that is never fun. I don't think this piece is the right size. Hold on just a moment. I'm going to do something noisy. Hold, please. I'm going to see if I can break one of these pieces. Hold on just a moment. All right, so let's see. Grab my gloves. Pop in these last two pieces. Okay, put in a little bit more warm water. It works a lot better if you can get the dry ice into the balloon, but because my piece is sublimated, unfortunately that wasn't possible. So there we go. And that should be a lot more, so it should blow up quite a bit more. So this is a really cool chemical reaction, because you can actually see, I mean, some of the carbon dioxide is in the container, obviously, but quite a few of it went up into the balloon. The cool thing about this comet is if you finish with your comet and you're a little sad that the comet died on you, this is basically what happens when it gets to Jupiter's orbit. It stops sublimating. If you add some more water to it, it will start to sublimate again.
Oh, neat.
So you can restart your comet. I had a student who thought it was so cool when we were finished, but it had stopped sublimating. And he's like, "Can I take a picture?" And I said, "Sure, just put a bunch more water in there." And, ooh, excellent.
Starts up again.
See, what a good job.
That's really cool. Well, thank you very much, Tanja. This has been very fun. I know everyone in the audience asked great questions. I'm going to go ahead and bring up our last slide here. If you'd like to contact the library, you can call us at the number on the screen at 813-273-3652, or you can go online at hcplc.org/contact. And also, as I mentioned at the top, you can see all of our summer reading programs and activities and book lists and all of that at hcplc.org/summer. And with that, I'd like to say thank you to Tanja, and thank you to everyone who came this evening to watch the program. Have a great evening, everyone, and we will see you soon. Good night, Tanja.
Goodbye.
Bye, everybody.